questions. This video we shall discuss about the further pure 2000 paper 2 2021 May June paper 21. Let's take a look at the questions. 1a. Given that a is an integer, show that the systems of equations here has a unique solutions and interpret this situation geometrically. So to show that it has a unique solution, that means you need to show that the a cannot equal to 0. Okay, and the determinant cannot equal to 0. Sorry, it's a determinant not equal to 0, not a equal, not equal to 0. So the determinant will be this. Take the coefficients of the x, y, z out. You cannot write equal to 0. You cannot write not equal to 0 as well. You need to show that they are not equal to 0. So from here, just the determinant, expand them. You get -5 minus 6, -3. You have a -10 plus 3. And you have 1, 4 plus 1. Okay. So at the end, you get -11a plus 26. So because they mentioned that the a is an integer, okay, so you just let this equal to 0. Okay, we let this one equal to 0. And you will see that your a is actually 26/11. Okay, this is not integer. Okay, so over here, this one is not integer. It's not integer. Because of a is integer, therefore a not equals to 26/11. And that will give you -11a plus 26 is not equal to 0. So because this is not equal to 0, that means the determinant is not equal to 0. Therefore, your systems of equations over here has a unique solution. Okay. So therefore, unique solutions. That means this is right. Therefore, the system of equations has a unique solution. Okay, that's all. Let's write that. Then we need to interpret the situation geometrically. If you have a unique solution, that means the three plane will intersect at a point. Three plane will intersect at a unique point. That's all. Okay, so this is the answer for the number 1a. Now we move on to the number 1b. Find the value of a which the x equal to 1, y equal to 4, and z equal to -2 is the solutions to the systems of equation in part A. Okay, so they are giving you, we just take this equation out, ax plus 3y plus the z is equal to 14. Okay, so we just replace these three values inside here. You can get 14. Then therefore you can find the a. So you have a multiply 1 plus 3 multiply 4 plus -2 is equal to 14. Therefore your a will be 12, then 4. Your a is a 4. Okay, done. So this is the answer for the number 1b. Move on. We have question number 2. The differential equations over here. The variable x and y are related to the differential equations following here. Find the general solutions for y in terms of x. They want y in terms of x. So first of all, we just take the AE out, which means the m squared plus the 3m plus the 2 equal to 0. You factorize it, finding the root. You will see that your root is a -2 and another root is a -1. So your complementary solutions will be AE to the power of -2x plus the BE to the power of -x. Okay, we have done with the complementary solutions. Now we want to go for the particular integrals. So for particular integrals, we let the yp equals to, this is a linear. So the general form for linear will be px plus q. Px plus q. Uppercase. So you will be having your yp prime, which is a p, and your yp double prime is a 0. So you just replace them inside the equation. It will be yp double prime plus 3yp prime plus 2yp is equal to the 2x plus 1. So you will be having 0 plus 3p plus the 2px plus q is equal to the 2x plus 1. Expand, simplify, you will have 2px plus the 3p plus 2q equal to the 2x plus 1. By comparison, p is equal to 2. That means the p is equal to 1. 3p plus 2q is equal to 1. 3 plus 2q is equal to 1. Therefore, your q is a -1. So you found the p and q. So your yp will be the x minus 1. Your general solution is y equal to the yc plus yp. yc plus yp. So your yc just now is ae power -2x plus b power -x plus your yp is a x minus 1. So this is your general solution. Done. Okay, so now we move on to the part B. They want you to state and approximate solutions for the large positive value of x. So for the large positive values of x means your x is approaching to infinity. Okay, so what you need to do is just to write the y is equals to the limit of x approaching to infinity of ae power -x, sorry, -2x. Okay, so when the x is approaching to infinity, this will approach to 0. Okay, that means this will approach to 0. E power -2x also will approach to 0. So these two will become 0. So at the end, so you just say that when the x approach to infinity, e power -2x is approached to 0, and e power -x is also approached to 0. Therefore, your y is only approaching to the x minus 1. Okay, so this will be the answer. However, you can see that the approximate solutions, they want approximate solutions. So over here, actually we just say equal to the x minus 1. Okay, this solution is approximate. So the solution will be approximated to x minus 1. Okay, so this is the answer for the number 2b. Move on. We have question number 3. Over here shows the curve with equations of y equal to x cubed for the x between 0 to 1 inclusive, together with the n set of the rectangle with the width of 1 over n. Okay, so they want you to consider the sum of the areas of the rectangle, show that the integrations of 0 to 1 of x cubed is less than the UN, where the UN look like this. UN is the upper bound. Okay, so what you need to do is, first of all, you need to understand that this one we need to integrate. This one we need to find the series. Okay, series of the area. We just break the area into a lot of rectangles. Then we're going to find the sum of the area of rectangle. So first of all, we let this as a fx, the function x cubed. Okay, so if you integrate 0 to 1 x cubed, less than means what? Less than means the area of rectangle is the height of the rectangle is actually higher than the graph. It's actually higher than the graph. So this will be your first rectangle. No, actually your first rectangle is here. This is your first rectangle. So your first rectangle, the height is coming from 1 over n. So it's a f 1 over n multiply 1 over n plus f 2 over n multiply 1 over n plus until the last height. Last height is f1. So f1 is actually fn over n. So this will be equal to the 1 over n, the sum of the f r over n, r from 1 until n. So this is what we have. Oh, okay. Yeah. Over here, I use equal sign because at the first statement, they are inequalities. But for the second statement, is actually the equal sign is because this expression is equal to this sum. Okay, so just in case you are wondering. Okay, so over here, I will use equal sign. Then this will be replace the variable r over n inside this function. Then you will get r cubed over n cubed. R is a variable, n is a constant. You can take the constant out, you will get power 4. And inside here, you will get r cubed. So this formula, you can get it from the formula booklet MF19, the sum of the r cubed. So over here, I will write it out to make it become n square, n plus 1 square over 4. And you can see that this square and this can be cancelled. So at the end, what do you get? At the end, you will get this as the n plus 1 square over 4n square. So therefore, your integration is less than n plus 1 square over 4n square, and your un is equal to the n plus 1 square over 4n square. Okay, so this will be the answer for the part A. Okay, then part B, they want you to use a similar method. This time is to find the lower bound Ln. So to find the lower bound Ln, repeat the same method. So this time, your integration of s cubed, it will be greater than. So now if it's greater than your area of triangle, area rectangle, the first rectangle, you must choose the lowest, then here, and then until here. So the lowest will be f0 over n. So you started with f0 over n, multiply 1 over n, plus f1 over n, multiply 1 over n, plus until fn minus 1 over n, 1 over n. So this will be the same as n minus 1. Okay, we can factorize the 1 over n out. Okay, you can factorize the 1 over n out. Because if we want to use a formula, the r must start from 1. So what you need to do over here is to separate it f0 over n, and this one you can write it as a start from 1. Then it will be r over n cube. So now f0 over n actually is a 0. Okay, it's actually is a 0. Then this one, it will be r cube over n cube. So we factorize the n cube out, you get n power 4. And again, inside here, these expressions, we will use the formula because the sum of the r square, r cube is equal to the n square, n plus 1 square over 4. This is n. But if your n is if your n changed to become n minus 1, then all the n here have to become minus 1. So this will become n minus 1 square, n square over 4. And if you expand them, you will get this as the n minus 1 square over the 4n square. Okay. So that means your ln is equal to the n minus 1 square over the 4 square. That will be the answer for the part B. Oh, I'm sorry. I just realized that they want you to show like this. Okay, I didn't show it. So I need to make it become this. Okay, shown. Then this one we also follow our ln. We will follow the same pattern, and we can make it become n minus 1 over 2n square. Okay, done. That is the answer for the part B. Now we move on. We go for the part C. We have the un minus the ln less than 10 to the power of negative 3 is 1 over 1000. So what is your un? Your un is a un is a n plus 1, the 2n, minus the n minus 1 over the 2n. We can just expand and simplify. So expand, simplify, you get n squared plus 2n plus 1 minus the n squared plus 2n plus minus a 1 over the 4n squared. Combine these two fractions become 1. So you can see that this one cancel, 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 cancel. At the end, you have 4n over 4n squared. So as you get this, then your n will be greater than 1000. So your n minimum will be 1001. 1001. Done. So this will be the answer for the question number 3C. Moving on, we have question number 4. Look at question number 4. We have a first order differential equations over here given as a sine theta dy d theta plus y equal to the tangent half theta, where the theta is 0 to pi, given that y equal to 1 when theta equal to pi over 2. Find your answer in the form of y equal to f theta. And they give you a hint that we may just use this result directly, okay, without proof. So over here you have sine theta dy d theta plus y equal to the tangent half theta. We will be using the integrating factor. So you will be multiply them and divide everyone by sine theta. Then your IF is equals to the integrate 1 over sine is a cosecant. Then we can make use of this result. Cosecant integrate, you get log tangent half theta. So you get e power log tangent half theta. Then according to the form, the rules, I mean the index law of indices, e power ln of anything will be equal to the function itself. Okay, so we will be using this formula and we will get the answer of the IF as the tangent half theta. So now we take this whole thing over here, we multiply them by the IF. So you will get tangent half theta plus the tangent dy d theta, sorry. And you get tangent square. Okay, so this is what we have. Then we know that the left-hand side, after you multiply by IF, the left-hand side can be written as the implicit differentiations of tangent half theta multiplied by y. The right-hand side, maybe we can simplify them further. You can use a double angle for the sine theta, or we call it a half angle theorem. 2 sine half theta cos half theta. You can do like this. Then this one, you will be integrating the tangent half theta. Y is equal to integrate. We need to simplify it. Here, we will get this one as the half sine half theta half theta power -3 d theta. We will write like this. Okay, we will write like this. Then the left-hand side, we just integrate it. You will get tangent half theta multiplied by y. The right-hand side over here, we will apply the formulas of f prime, fx power n dx. We apply this formula. We call this one the power rule. Okay, so you just need to make sure that this is the f prime. This is the f prime. This is the f. Your f is a cos half theta. Cos half theta differentiate will give you negative half sine half theta. Oh, there's a negative. So over here, you integrate, you will get negative cos half theta negative power 2 divided by -2 plus the c. So you will get this one as the half secant square half theta plus c. Okay, so you get something like this. Then we need to find the c. So to find the c is when theta is equals to the pi over 2, the y is a 1. So theta equal to pi over 2, then you get tangent pi over 4 multiply 1 is equal to the half of secant square pi over 4 plus c. So your c tangent pi over 4 is a 1. 1 minus the secant pi over 4. Secant pi over 4 is a 2. So this one, 1. C is a 0. Nice. Okay, then we can, we need more space. Okay, so we will go and find solve it. We want the answer in the form of y equal to f theta. So you get your tangent half theta multiply y is equal to the half secant square half theta. So we will have this as the Over here, I think we don't, I think we can still simplify the trigonometry expressions over here. So we try to simplify it. It's up to you, because actually this is not wrong as well. The answer is not wrong. It's just that if we can simplify further, we will try to simplify further. So we can see that we actually have a half sine half theta. No, half multiplied by 1 over sine half theta and cos half theta. Oh, okay. So this one you have sine theta. Okay, by applying the double angle formula, this whole thing, you can make it become sine theta. So your y is equal to the cosecant theta. So this answer will be better. Okay, so we are done. This is the answer for question number 4. And now we move on to the question number 5. Sum of the series of this for the z not equal to 1. So over here, we know that this is a GP, geometric progressions, z plus z squared plus the z cubed plus until z to the power of n is equals to the formula for geometric sum of the n terms in the GP will be a r power n minus 1 over the r minus 1. Okay, so your first term is a z. Your common ratio is also a z power n minus 1 over z minus 1. So this is the answer. Done. Of course, you can choose to expand them, become this if you want. Expand the numerator, but that is up to you. So that is an answer for number 5A. So now we move on to the number 5B. They given that the z is an unity, is an n root of unity. So the meaning of n root of unity means z to the power of n is a 1. And we want to deduce this result is true. So from A, already know that z plus z squared plus z cubed plus until z power n is equals to the z power n minus 1 over z minus 1. So from part B, given that the z power n is equal to 1, so the left hand side, you can factorize it out. This will be the 1 minus 1 over the z minus 1. So this whole thing will be a 0. Okay. So that means is equal to 0. That means the z is a 0, or the 1 plus the z plus z squared plus until z to the power of n minus 1 is equal to 0. Either the z is a 0 or the whole thing here is a 0. Over here, z is not 0. Ignore it or reject it. Okay, because if z is a 0, then the whole thing here, it will be 0, 0 square, 0 cube until 0 power n. Actually, that is not really meaningful, not really meaningful for us to have the z equal to 0. Okay, so yeah, so we ignore it. Okay, for this case, we ignore the z equal to 0. So now we move on to the C. Given that the z is equals to the 1 over 3 cos theta plus I sin theta, use the Morphy theorem to show this result. Okay, so you can see that this expression have imaginary and the real part, and you only want cos. This is a cos. That means we only want to consider the real part. Okay, but we need to start from here first. Let z equals to the 1 over 3. Not let, given, given z equals to the 1 over 3 cos theta plus I sin theta. And the sum of the z power r, sum of the, this is the m, will be equal to the, oh, this one is to infinity, yeah, to infinity. So to infinity, this will be equals to the a over 1 minus r, the formula. So formula to s infinity for the geometric progression is this. Okay. So your left hand side, you continue to replace the z, become 1 over 3 cos theta plus I sine theta, power of m. Then this one you will write like this. Of course, I can change the z, and z over here become this. But over here, we know the trick. You need to know the trick that we actually a bit troublesome. Over here, we want to multiply the conjugate because this one is complex. This one is also complex. So a complex number divided by a complex number, you still get a complex number. So the thing is that we want to realize the denominator, and to realize the denominator, we multiply the conjugate of the denominator. So to multiply the conjugate of the denominator, then is the same as this. Okay. At the meantime, your left-hand side, it will become this by applying the de Moivre theorem. You have 3 to the power of negative m cos m theta plus I sine m theta. So this is the de Moivre theorem. Then we expand this, we will get this. Okay, so how do we simplify them? So over here, we need to spend some explanations over here. So the z conjugate will be 1 over 3 cos theta minus the I sine theta. We need to highlight to the examiner that the conjugate for the z, will be like this. Then z plus the z conjugate will be the plus together. You will have only 2 over 3 cos theta. You need to show this result. And the z multiplied by the z conjugate, it will be actually the 1 over 9 only. So you need to highlight these two results. So we're going to apply this result over here. Okay, apply the result over here. Then you will get the z. It will be 1 over 3 cos theta plus I sine theta minus the 1 over 9 divided by 1 minus the 2 over 3 cos theta plus the 1 over 9. Okay. Now we only want to consider the real part. So the real part will be only this is the real part. And this is the real part. Okay, by consider the real part. So you get this 3 to the power of negative m cos m theta is equals to the 1 over 3 cos theta minus a 1 over 9 divided by 10 over 9 minus a 2 over 3 cos theta. Multiply everyone by 9. Then you will get 3 cos theta minus 1. The 10 minus the 6 cos theta shown. So this is the answer that they want you to show. Yeah, done. Correct. Okay, so now we move on. We have question number 6. We have a matrix A given as the following expressions over here. We want to find the matrix B and the diagonal matrix D, where the A square is equal to the PDB inverse. Okay, so of course we need to find the eigenvalue. So for the eigenvalues, you no need to use a very difficult way to find it, because this diagonal here is your eigenvalue. Okay, as long as the lower triangle here all 0, then your eigenvalue will be this 3. Okay, so your eigenvalue will be 5, -6, and 1. So I call it lambda. Lambda 1, lambda 2, and lambda 3. 5, -6, and 1. Okay. So now we want to find the eigenvector. So to find the eigenvector, we just say that when your lambda 1 is a 5, then your matrix over here, each and every one in the diagonal all minus 5, you get a 0, -22 over 3, 8, 0, -11, 0, and 0, 0, and -4. So we can just take any 2 rows, because none of them are parallel. So you just take any 2 rows. So I just take the first 2 rows. Then I get this as a 88. I plus the 0j plus the 0k. Oh, so we can take the 88 out. We have a 100. Therefore, your eigenvector number 1 is a 100. Okay, now we go for eigenvector number 2. Lambda is a -6. So your matrix this time, the diagonal all -6, all minus -6, all minus -6, it will be a negative, no, 11. -22 over 3, 8, 0, 0, and 0, 0, 7. So the middle row, all 0 cannot be used. So we will take the first and the third row. So take the first and third row to find the cross product. So this will be 11, -22 over 3, 8, and 0, 0, 7. Just calculate it yourself. You get this as a -154 over 3i plus the 77j plus the 0k. So you can factorize the -77 over 3 out, and you get 230. So therefore, your eigenvector number 2 is a 230. Then eigenvector number 3, when the lambda 3 is 1, we place it inside. Oh, this one all 0. Then this one, it will be 0. 6 minus 1 is 5. Then it's a 0. -1. Oh, no, sorry. -1 is a -7. So your eigenvector, cross product of these two planes, then you get 56i plus the 0j minus the 28k. So factorize the 28 out, you get 2, 0, negative 1. So your eigenvector number 3 will be the 2, 0, negative 1. So therefore your B is equals to the eigenvector number 1, eigenvector number 2. Just now eigenvector number 2 is 2, 3, 0. Eigenvector number 3 is a 2, 0, negative 1. And your A square is equal to the B inverse. Okay, that will be the diagonal vector. Diagonal vector will be 5, negative 6, 1. It's squared. So therefore your D is equal to this. So you get 25, 36, and 1, and the rest are 0. Done. This will be the answer for the question number 6A. Now we move on to the 6B. Use the characteristic equation to find A cube. So to use the characteristic equation to find A cube, so first of all, we need to find the characteristic equation. Characteristic equations. That will be your lambda 1, lambda 2, and your lambda 3. This one is a 6 plus 6 minus 1. These all of them are the root. Okay, so you expand them. Expand it yourself. Over here, lambda square plus lambda minus 30. You get lambda cube. Minus 31 lambda plus the 30. So from CAIE-Hamilton theorem, we have A cube minus the 31A plus 30I is equal to the 0 matrix. So your A cube is equals to the 31A minus the 30I. So 31A, just write down the matrix. Identity is a 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. Then matrix A is a 5, 0, 0. Okay. 6, negative 22 over 3, and 8. So expand, simplify, then you will get the answer as 125, negative 682, divided by 3, 248, negative 216, 0 and 1. Okay, so this will be the B, answer for B, A cube. We want to find A cube, answer for B, A cube, done. Moving on, or question number 7. Okay, so moving on, we have question number 7. Cos y in terms of x, and hence show that the sin y dy dx is equal to the negative 1 over x plus half square. So what you need to do is convert the inverse hyperbolic function into just hyperbolic function. So you have a sec y is equals to the x plus half. Then sec y is actually 1 over cos, or we can just write cos y is equal to the 1 over the x plus half. Then you differentiate it by using implicit differentiation. You get sin y dy dx is equal to the negative of 1 over x plus half squared. Okay, so done. So this is how you show it. Shown. That is the answer for part A. Now we move on to the part B. Part B is to find the first three terms of the Maclaurin series for the functions over here, abstract of x plus half, in the form of ln a plus bx plus cx squared, and a, b, c are the constant to be determined. So what we need to do over here is we start from here. So to make our process easier, we will just repeat whatever we have done earlier. Okay, actually we can straight away copy the result in the part A. So we have cos y is equals to the 1 over the x plus half. Okay, then we have sin y dy dx is equal to the negative 1 over x plus half square. Okay, so we just copy the result from part A first. Then we just replace 0 inside. When the x is a 0, you have a abstract of 0 plus half. So this is actually the cos of 2. Just go for the formula booklet, MF19, look for the formula. It will be x plus the square root of x squared minus 1. Replace x as a 2, then you get ln of 2 plus 3. Okay. Then after that, we need to know that the sin ln, we need to know the sin y. Okay, when the x is a 0, your sin y, sin 2 plus 3. This one you can just use a calculator. So this one you can check with the calculator that this is a 3. Okay, then the cos of the y is 2. So this one you can check from the calculator. Hey, no, sorry, make a mistake. Cos ln of 2 plus 3 is actually a 2. Okay, so this is what you need to get ready first before you continue. So now when the x equal to 0 again, so okay, so from here you get sin of ln 2 plus 3. By dx, that will be your y prime 0 is equal to the negative 1 over the 0 plus half square. So you will get this as the negative 1 over 3 of 1 over 4. Okay, because this one is actually 3. Okay, it's a 3. So we just replace it inside, then simplify it. You will get this one as a negative 4 over 3. But I prefer to rationalize the denominator. So I will write like this. Then now we need to do one more differentiations. From here, we do the one more differentiation. It will be implicit differentiation. Sin y d square y ds square plus the dy dx. Sin y differentiate, you get cos y, and then dy dx again is equal to the 2 over the x plus half cube. Then when the x is a 0, your y is a ln 2 plus the 3. So your sine y, it will be the 3. Then the y double prime 0 plus the cos y. Cos y is a 2. So your dy dx, you square it, dy dx you square it, then you get the negative squared. Okay, then this one is equal to the 2 over the 1 over 8. Press the calculator, simplify it. You get your y double prime 0 is 16 sub 3 over 9. Okay, so this one you press it yourself. This one you press it yourself. You'll get the answer y double prime of 0 is 16 sub 3 over 9. So therefore, your function, your y will be equal to the, or maybe you just write arcsine, sorry, is equal to the y0 plus y prime 0 x plus the y double prime 0 x squared over 2 factorial plus a dot dot dot. So this one is a ln of 2 plus 3. This one is a negative 4 3 over 3x. Then this one, it will be 16 over divided to x 3 over 9. X squared. So this will be the answer for the question number 7b. And move on. We have question number 8. We have the curve C that has the equations of x equal to 2 cos t, y equal to the 3 over 2 t minus the 1 over 4 sine 2t for the t from 0 to 1. So we want to find the x dt and show that the dy dt is equal to the 1 minus sine squared t. So this one is typing error. Okay, this one is the x dt. Yeah. So how do you find the x dt? So to find the x dt, just differentiate from here. You get the x dt is 2 sine t. Then your dy dt differentiate from here. You get 3 over 2 minus the 2 over 4 cos 2t. But however, the question wants you to leave the answer in the form of sine squared t. So we just need to apply the identity. Cos 2t is 1 plus 2 sine squared. So simplify it, you will get 1 minus sine squared t. Okay, so it is the result that you will get shown. That is the answer for part A. Then for the part B, we are looking for the surface area generated 2 pi radian about the x-axis, and is denoted by A. We want to show that the A can be written as this. So over here, we just need to use the formula. But before we use the formula, we need to find out this expression first. We need to simplify these expressions. Dx dt square plus dy dt square square root. So it will be result from part A just now is a 2 sine t square plus the 1 minus the sine square t square. So if you expand them and simplify, you will get 1 plus the 2 sine square plus the sine to the power of 40. And then you factorize it again. Then you get this 1 plus sine square. 1 plus sine square is actually a cos square. Okay, 1 plus sine square is actually a cos square. So this is what we have. Then the surface area formula will be a 2 pi integrate from 0 to 1 y square root of dx dt square plus the dy dt square. Okay, so just need to replace the y. Just now the y is a 3 over 2t minus the 1 over 4 sine 2t. This one is a cos square t dt. Okay, so this is just replace it inside here, then you will get this result. Now, however, this is not the same as what the expression that they want you to show. We are having this correct already, but this one is 1 plus cos 2t. So we need to convert it to 1 plus cos 2t. So we know that the double angle, we try to relate with the trigonometry formula. So we have cos 2t is equal to the is equal to the 2 cos square t minus 1. Okay, so this is what we have. So the cos square t is actually 1 plus the cos 2t divided by 2. So we can apply this result. And then we have 2 pi 0 to 1, 3 over 2t minus the 1 over 4 sine 2t of 1 plus cos 2t divided by 2. So the 2 and the 2 here cancel. At the end, you're able to show that it can be expressed in this form. That is the answer for the B part 1, shown. Now, we're moving on to the B part 2. Hence, we want to find the value of A in terms of pi, sine 2, and cos 2. Okay. So over here, we will straight away integrate them. So we need to figure out how to integrate this. Let me just copy down the result here. The 1 over 4 sine 2t, sorry. Multiply by 1 plus the cos 2t dt. So for a very straightforward way of integration is we will just need to expand them. So have to be careful because it's, to expand them is kind of long. So we have 3 over 2t minus the 3 over 2t cos 2t minus a 1 over 4 sine 2t minus a 1 over 4 sine 2t cos 2t dt. So right here, you can see that this can integrate directly. This can integrate directly. This one, we also can integrate directly, but we will be applying this formula. F prime fx power n. We will be applying this result over here directly. Okay. So this one, we need to use integration by part to integrate it. Okay, so we will have to separate them, become 2 over here. So let me just separate it, become 2. This one is straight away integrate. Okay. This one straight away integrate, you get 3t square over 4 minus the 1 over 8 cos 2t. Then minus the 1 over 16 pi square. Okay, so this one integrate, I get this. This one integrate, I get this. This one integrate, I get this. So I integrate directly. Okay. Then left with the integration by part. Integration by part, I write over here, negative pi so over here, this one, I write over here. But however, we can also direct into the integration by part already. So let me just take it out. Integration by part over here is that you take out the 3/2t. There's a pi in the front. Integrate cos 2t, you get half sine 2t. So this one, it will be 3/4. 3/4t sine 2t. Minus the 3/4 sine 2t dt from 0 to 1. So we focus on this side first. So this side, if you replace the 1 and 0 inside, you'll get 3/4 minus the 1/8 cos 2 minus the 1/16 sine squared 2. Then minus with the negative 1/8 only. Then for the integration by part side, okay, this one is here. For the integration by part, let me just continue to integrate. You get 3/4t minus the sine 2t. Minus the 3/8 cos 2t from 0 to 1. This will be the integration by part side. Okay. So now we just need to replace the value over here. So this one, it will be 7/8 minus the 1/8 cos 2 minus the 1/16 sine squared 2 minus the pi. If you put 1 inside, you get 3/4 sine 2 minus the 3/8 cos 2 and minus with the negative 3/8. Now by combining everything together, so this and this combine together, you get 10/8. And this and this combine together, you get a half minus half cos 2. And minus the wait for a while. Let me check. Okay, correct. Okay, minus. Oh, I make a mistake. My apology. This is a plus. This is a plus. This is a plus. My apologies. This is a plus. Okay, then correct already. So it's okay. So this one is the plus the 3/4 sine 2. Okay, so this is the answer. This is the answer. But however, the answer that the one that I have and the answer that the mark scheme have is different. So if you check the mark scheme, the answer is by 3/4 sine 2 minus the 3/8 cos 2. Then minus a 1/16 1 plus cos 2 square plus 11/8. This is the answer from the mark scheme. So actually it's nothing special because you can see that this is the same. Okay. But the rest, all the value here and my value here all looks different. But if you expand this portion and simplify it, you're supposed to be able to get the same answer as mine. So let us just try to expand over here to check whether my answer and the mark scheme answer are tally. So this one, it will be 1 plus 2 cos 2 plus the cos square 2 plus the 11 over 8. So this one, if you join it together, then you get 3 over 4 sine 2 minus the 2 minus the 1 over 16 cos square 2, and then 22 minus 1. 22 minus 1 is 21 over 16. Okay. So this one, if you simplify further, this one you get a half. This one is a cos square, but my one is a sine square. So what is the relationship between cos square and sine square? Is 1 plus the sine square. So if you simplify further, then you can see that my answer and the answer in the mark scheme are the same. So this one you get minus the 1 over 16 sine square. This one is a plus the 20 over 16. 20 over 16 is 10 over 8. There you have it. My answer and the answer here are the match. Okay, just for your information. Okay, so that's it. This is the answer for the question number 8, and this will be the last question for this paper. I will stop the video here. I will see you next time. Bye-bye.